Hello everyone, welcome back to our channel. Today we are going to discuss about from the current electricity, one of the very important topic, and in our daily life also it is playing an important role. And without this concept we can't think about the current and what are the applications and all this. What is that topic name? Electromotive force. Many people are confusing what is electromotive force and what is the potential here. See, first of all we are going to the what is the electromotive force. See, the amount of work is required to draw the charge throughout the circuit is called the electromotive force. That is the general definition. But internally, what is the concept of this one? Look here. We can take this battery. This electromotive force is E. And this is the key. And we are taking one external resistance R. See how it is working. Whenever we are operating this battery, that role is it is doing some positive work to maintain the potential difference. Means it is maintaining the two terminals. One is at high potential, we are calling positive charge. Another one is at low potential, that is called the negative charge. You know that always charge is moving from high potential to the low potential. So because of this maintaining of this potential difference, the current is flowing through the circuit and we are enjoying all the fruits from that. But what is the electric field? See here, electric field also it's there. Suppose two terminals we are taking, one is positive, another one is the negative. Whenever we are maintaining the electric field, see all positive charges are moving from negative to positive and positive to negative, and all negative charges are moving from negative to positive. See, at the time the role of the electric field, in this case it is 0. That's why integration of E bar d dot dl equals to 0. But what is the role of this battery? But this battery is doing the positive work. What it is doing inside that, suppose we are taking clocks also, we are using cells and electrolyte materials. There it is forcefully pushing the positive charge from negative to positive. Because of that reason, one is at high potential, another one is at low potential. This is at high potential positive and this is at low potential. Here also we can represent positive, negative. That's why the role of battery is nothing but electromotive force. The definition is the amount of energy is required to move the unit positive charge entire circuit externally as usual internally. That is called the electromotive force. What is the unit for electromotive force? Volts. Then how to take the potential formula here? See, work done equals to as usual force into displacement. Between these two terminals, forcefully it is pushing that positive charge. No? How much force is there? F. In terms of intensity, EQ into L. But E into Q, E into L is nothing but potential VQ. Then V equals to W by Q. So W equals to VQ. The amount of work is required to move the charge throughout the circuit is called the electric potential. But here we are discussing about this battery, means this potential is nothing but it is called electromotive force. We are representing small e or epsilon and all this. Epsilon equals to W by Q. Then unit for this one is volts. And one more topic is internal resistance. What is the internal resistance? Internal resistance is represented by small r. Here internal means inside the battery, internally the resistance offered by that one is called the internal resistance. Always we are thinking, yes, one source is there, it is maintaining the potential difference and that one. But inside that exactly it is not working. Some internal opposition of that one is there, opposition of that charge, that is called the internal resistance. It is represented by small r. Now we are going through the different conditions. One side I am taking the situation, another side I am taking potential difference across the terminals of the cell. First one is we are taking charging. Suppose our phones are there, we want to put the charging. At that time we can take it, this is the battery. Charging means arrowhead is towards this one and it is internal resistance. In this condition you can consider this is the point A and this is the point P. What is the potential difference across this one? Here electromotive force is epsilon. See, potential difference is across the two points. We can find out the potential difference. Electromotive force is, this is due to the battery, it is represented by epsilon. In this case, in the case of charging, what is the potential difference? See, VAB, potential difference across AB is epsilon plus IR. I is the current passing through the circuit, R is the internal resistance. And one more condition, discharging. See, discharging means it is looking same, resistance R, the point B, and here you see this arrowhead is away from this positive charge. In this case, and here you can say VAB is greater than epsilon, electromotive force. Why? Here epsilon plus IR is there. And this discharging condition, potential difference across this is VAB equals to epsilon minus IR. So VAB is less than epsilon. Then another condition, we can go through the open circuit and closed circuit. What is open circuit? Across the open circuit, what happens? Here same we are taking this one, internal resistance. There is no external resistance, condition AB. Here electromotive force is equals to potential difference, both are same. Then closed circuit, instead of closed we can take a short circuit. Closed circuit later we discuss. Short circuit, here we are not connecting any external resistance. In this case, electromotive force epsilon minus IR is equals to 0. Here epsilon equals to IR. This is about this short circuit, open circuit, discharging condition, charging condition. That is about the electromotive force. And always we remember that electromotive force depends on the nature of the material. It is the cause of that potential difference. But here when we can go through the potential difference across any 2 points, that is the effect. It depends on the external resistance. So that is the difference between potential and electromotive force. Based on electromotive force, now we are discussing few problems, like one problem only. Suppose always we are interested to drive car and we want to go to a long run. At that time what happens, and what about that battery situation in the car we are discussing. First of all, when the car starts, the motor will run. The question is, that battery is having the 12 volts. That car battery is having the 12 volts and internal resistance is 5 into 10 to the power of minus 2 ohms. 5 into 10 to the power of minus 2 ohms. When motor starts, how much current it is drawing? I equals to 90 amperes. Then we should find out what is the potential difference of that battery across the 2 points. How to find out? We know the electromotive force, we know the internal resistance, and we know the how much current it is drawing. This is main point. It is drawing means, is it charging or discharging? Clearly it is the drawing, taking the current means that is the discharging condition. In the case of discharging, just now we know that what is the potential difference formula? V equals to epsilon plus IR. Here epsilon is how much? 12 volts. Current is the 90 and internal resistance is 5 into 10 to the power of minus 2. Discharging means here we are getting minus into 10 to the power of minus 2. After simplification we are getting 7.5 volts. Now you see clearly, electromotive force is 12 volts and this potential difference is 7.5 volts. So here in the case of practically we know that discharging condition, potential difference is less than electromotive force. And continuation of this problem, see, we are running that car like 12 hours, 24 hours, 48 hours, like that, continuously running. Then what happens? Internal resistance is increased from 5 into 10 to the power of minus 2 ohms to 50 ohms. That internal resistance is increases. At that time, what is the current? How to find out the current in this case? As usual, same formula. I maximum equals to electromotive force. It is not changing. It is permanent of that cell. 12 by that resistance is 50. After simplification, 2.4 into 10 to the power of minus 1. It should be right 24 milliamperes also. See, because of running, whenever internal resistance is increases, current is decreasing. Beginning how much is there? 90 amperes. Then 24 milliamperes is there. Then continuation of this one. See, after running, that battery is discharged condition completely. Now we want to put that charging. In future we are going through the electric cars and all this. We can observe this condition also. See, then discharged battery is charged. Now that discharged battery is over. Now we are charging that battery. Charging that battery means what we are taking? V equals to epsilon plus IR. Epsilon plus IR. So we can take it V equals to epsilon is the 12 volts. Current is based on that condition. But here depends on the situation. We have to do the calculations. Here current is 90 amperes. Then internal resistance is 5 into 10 to the power of minus 2. After simplification, V must be greater than electromotive force. So practically we can observe the battery in the case of charging, in the case of discharging. Then if we are running, internal resistance is increases and how much maximum current it is drawing. These are the examples for that. Thank you. Please subscribe my channel.